Have you ever been on a train ride so smooth it felt like you were floating? Now imagine the engineers responsible for that smoothness decided the best material for the wheels was paper. Not steel, not rubber, paper. And not just any paper, compressed, laminated, industrial paper stacked so tightly it became something almost unrecognizable from what you pull out of your printer. This sounds completely ridiculous, and honestly, the first time you hear it, it kind of is. But here's the thing. It actually worked. And for a few decades in the late 1800s, paper wheels were considered the gold standard of luxury rail travel in America. What even is a paper wheel? Before we go any further, let's clear something up, because when most people hear the words paper wheel, they picture someone gluing together a few sheets of printer paper and slapping it onto a train axle, which, to be fair, would make for a very short and very dramatic train journey. Not exactly the gold standard of luxury travel. That is not what we are talking about here. A paper wheel was a wheel constructed using hundreds and sometimes thousands of individual sheets of compressed paper, layered and pressed together under enormous hydraulic pressure to form a dense, solid disc. Think less origami, more industrial manufacturing. This disc was then sandwiched between two steel plates on either side and bolted onto a steel hub and outer tire. So the rim that actually contacted the rail was still steel. The paper was not out there grinding along the tracks every day, taking the full force of a loaded passenger carriage. What the paper did was sit in the middle, between the hub and the rim, acting as the structural and shock-absorbing core of the entire wheel. The finished product looked from the outside almost identical to a regular train wheel. You would not have known it was paper unless someone told you. And even then, you probably would not have believed them, because the disc itself was extraordinarily dense. We are not talking about something you could tear or bend or fold. This material was hard, closer to wood than to anything you would find in a notebook. And in some tests conducted at the time, it actually proved more durable under certain conditions than cast iron, which is the point where most people stop and say, wait, seriously? Yes. Seriously. So the question becomes obvious. Why paper at all? If the outer rim is steel and the hub is steel, why not just fill the middle with steel too and be done with it? To answer that, we need to go back to the early days of railway travel and understand just how genuinely unpleasant the experience actually was for the people sitting inside those carriages. The problem with early railway rides. Let us set the scene. It is the 1840s and 50s. Railways are spreading across America and Europe at a remarkable pace, and people are genuinely excited about this new form of transportation. You can travel distances in hours that would have taken days by horse and carriage. That part was revolutionary, but the ride itself, absolutely terrible. Early railway wheels were made of cast iron and later wrought iron and steel. The rails they ran on were also iron and steel. So you had two incredibly hard, completely rigid materials slamming against each other at speed, and every single imperfection in the rail, every joint, every gap, every slight misalignment sent a shock directly through the wheel, up through the axle, through the carriage floor, and straight into the spine of every passenger sitting inside. People described early train journeys as exhausting in a way that had nothing to do with the distance traveled. The constant vibration and jarring was genuinely fatiguing. Passengers arrived at destinations feeling rattled, literally. Fine china in dining cars rattled itself off tables, glassware cracked, and the noise inside the carriages was significant, that rhythmic clacking and rumbling that never really stopped for the entire journey. Now, for short working class trips, this was unpleasant but acceptable. You got where you were going, fine. But a new class of traveler was emerging in America in the 1860s and 70s. These were wealthy passengers who expected their train experience to reflect their status. George Pullman was building sleeping cars and parlor cars that were essentially rolling hotels. Velvet curtains, mahogany paneling, gas lighting, fine dining, everything about the interior screamed luxury. Everything except the wheels underneath, which were still hammering away like a blacksmith's workshop every time the train hit a rail joint. The ride quality was the one thing nobody had solved. And that embarrassing contradiction, a luxury hotel sitting on top of a mechanically brutal chassis, was the problem that a man named Richard Allen decided to fix. How the paper wheel was invented. Richard Allen was a Massachusetts inventor, and in 1847 he received a patent for something that, on paper, no pun intended, sounded almost laughably simple. He proposed replacing the solid middle section of a railway wheel with a compressed disc made from layers of paper. Now you have to appreciate the context here. In 1847, the dominant engineering philosophy was that harder meant better. Cast iron, wrought iron, steel, these were the materials of serious engineering. Paper was for books and letters and wrapping parcels. Suggesting paper as a structural railway component was the kind of idea that probably got Allen some very confused looks in engineering circles, but Allen had noticed something important. Paper, when compressed under extreme pressure, does not behave like paper anymore. The fibers lock together, the air is driven out, and what you are left with is a dense, fibrous composite material with properties that rigid metals simply do not have. Specifically, it can absorb energy. It flexes microscopically under load and returns to shape. Steel does not do this. Steel transmits force, and in a railway wheel that means every shock from the rail travels straight through with nowhere to go except into the carriage and the passengers. Allen's compressed paper disc acted as a buffer. When the wheel hit a rail joint or an imperfection, the paper core absorbed a portion of that shock before it could travel up into the vehicle. The result was a measurably smoother, quieter ride. The process of manufacturing these wheels was not simple. Sheets of paper, often specifically manufactured for the purpose, were stacked in precise orientations, then subjected to hydraulic pressing at enormous pressures. The resulting disc was then machined to exact tolerances and assembled between the steel components. Quality control mattered enormously because any inconsistency in the disc could create imbalance in the wheel at speed, and an unbalanced railway wheel at speed is a problem nobody wants. It took years for the idea to gain real traction, but by the 1860s and the 1870s, paper wheels began appearing in a very specific and very important place on the American railway network. How it actually worked, the engineering. Let's take a slightly closer look at why paper specifically worked so well here, because this is the part that genuinely surprises people when they understand it. Steel is what engineers call an elastic material, which sounds like it should mean flexible, but in this context means something more specific. Under load, steel deforms very slightly and then springs back. But steel's elasticity is very high, meaning it resists deformation strongly and returns force rapidly. This is great for structural applications, not so great when you are trying to absorb vibration. Paper fibers, when compressed together, create a material with a much lower elastic modulus. It absorbs energy rather than returning it instantly. In modern engineering terms, you might compare this to the difference between a rubber bushing and a solid metal joint in a car suspension. One transmits force, the other dampens it. The laminated structure also mattered. Because the paper was built up in hundreds of individual layers, rather than cast as a single homogeneous piece, it had natural internal boundaries where energy could be dispersed. This is actually a principle you find in modern composite materials and even in the design of some aircraft components. Layers beat solid construction when vibration absorption is the goal. The paper wheels also had another unexpected advantage. They were lighter than a comparable solid steel wheel. In railway engineering, UN-sprung weight, which is the weight of components not supported by the suspension system, directly affects ride quality. Less UN-sprung weight means the wheel follows the rail more gently and transmits less shock to the vehicle above. Paper wheels reduced unsprung weight meaningfully, which compounded the smoothness improvement even further. And here is the detail that really surprises people. In independent tests conducted in the 1870s and the 1880s, paper wheels in certain conditions outlasted cast iron wheels in terms of wear and structural integrity. Cast iron was brittle. Under repeated impact loading, it could crack. Paper, bizarrely, was more forgiving. Who used them and where? Paper wheels found their most enthusiastic home on Pullman cars, and this makes complete sense when you think about it. George Pullman was not just selling transportation, he was selling an experience, a feeling, a lifestyle on rails. His entire business model depended on wealthy passengers actively choosing to travel by train rather than staying home or finding alternative ways to get where they were going. Every vibration, every loud clack from a rail joint, every rattling glass on a dining car table was essentially an argument against buying a Pullman ticket. A very expensive argument. So when Paper Wheels demonstrably quieted and smoothed the ride of his carriages, Pullman did not need much convincing. He adopted them with real enthusiasm. By the 1870s, paper wheels were standard equipment on Pullman sleeping cars and parlor cars operating across major American long-distance routes. If you were riding in comfort across the United States in that era, there was a very good chance you were doing it on compressed paper and just had absolutely no idea. Now there is a class dimension to all of this that is worth pausing on because it is quite revealing. Paper wheels were not cheap. The manufacturing process was labor-intensive, the quality control was demanding, and the specialized paper used in production was not something you sourced from your local supplier. All of that added up to a premium product that ended up almost exclusively on premium carriages, the ones the wealthy passengers rode in. Meanwhile, standard passenger cars and freight cars continued rolling along on rigid steel wheels, rattling away exactly as they always had. So the smoothest, quietest ride on American railways in the 1870s was quite literally rolling on paper. Rich passengers gliding through the countryside in their Pullman cars, with their champagne barely rippling in the glass, while everyone else was still being shaken around like loose change in a tin can. Honestly, as a piece of railway history, that feels very on brand. Outside of America, paper wheels barely made a dent. European railways prioritized heavy freight operations and ran on different wheel and rail standards entirely, so the luxury passenger comfort problem that paper wheels so elegantly solved was simply never the same commercial priority. It remained a uniquely American solution to a uniquely American market obsession with luxury on the move. Why did they disappear? If paper wheels worked so well, this is the question that always comes up, and the answer is not one single thing but a combination of factors that gradually made paper wheels obsolete. The first factor was the improvement of steel metallurgy. Through the 1880s and the 1890s, the quality and consistency of steel improved dramatically. New alloying techniques and better manufacturing processes produced steel that was tougher, more consistent, and less brittle than the cast iron and early wrought iron it replaced. As steel wheels became better, the gap in durability and performance between steel and paper narrowed. The second factor was rubber. Engineers began experimenting with rubber components, initially as inserts and cushioning elements within steel wheels, and eventually as more integrated parts of wheel and bogie design. Rubber had vibration dampening properties similar to paper, but with additional advantages in terms of flexibility across temperature ranges and resistance to moisture. Paper wheels had a known vulnerability to water. Prolonged exposure to moisture could compromise the compressed paper disc over time, which was a real operational concern. The third factor was the improvement of suspension systems. Early railway carriages had very rudimentary suspension. By the early 1900s, bogie design, the wheeled frames underneath railway carriages, had advanced considerably. Better suspension at the bogie level could now absorb much of the shock that paper wheels had previously been managing. When the suspension system itself improved enough to solve the comfort problem, the specialized wheel solution became less necessary. By the early 1900s, paper wheel production had declined significantly. By the 1920s, they had essentially disappeared from mainline railway operations. The problem they had brilliantly solved had been solved by other means, and the railway industry moved on, as it tends to do. There is something slightly melancholy about this, actually. A genuinely clever, genuinely effective engineering solution, consigned to history not because it failed, but because the world around it changed. That happens more often in engineering history than people realize. What this tells us about railway engineering. The story of paper wheels is actually a perfect illustration of something that comes up again and again in railway engineering history and in transport engineering more broadly. The best solution to a problem is not always made from the most obvious material. When engineers face a new challenge, the instinct is often to reach for the established materials and established methods. Make it stronger, make it harder, use more steel. But sometimes the problem requires a completely different kind of thinking. The problem with early railway ride quality was not that the wheels were too weak. The problem was that the wheels were too rigid. More steel would have made things worse, not better. Richard Allen understood that the problem required a material that could absorb energy, not resist it. And he found that material in something nobody in serious engineering circles would have considered. That willingness to look at unconventional materials and ask, what properties do I actually need here rather than what materials do we normally use, is exactly the kind of thinking that drives genuine innovation. You can draw a direct line from paper wheels to modern composite materials in railway construction. Today's high-speed trains use carbon fiber components, composite brake discs, and carefully engineered rubber and polymer elements throughout their construction, precisely because engineers understand that different materials serve different functions. Rigidity, where you need strength, compliance, where you need vibration control. The principle is identical to what Allen figured out in 1847. The materials are just a century and a half more sophisticated, so let's bring this all together. In the mid-1800s, early railway travel was fast but brutally uncomfortable. The rigid steel and cast iron wheels of the era transmitted every imperfection in the track directly to passengers, and this was becoming a serious problem as luxury rail travel emerged as a market. Richard Allen's solution, a wheel with a core made from hundreds of layers of compressed paper, sounds absurd on the surface, and yet it worked. The compressed paper absorbed vibration, reduced noise, lowered unsprung weight, and in some conditions outlasted cast iron in durability tests. Pullman adopted paper wheels for his luxury carriages, and for a few decades in the late 1800s, the smoothest train ride in America was rolling on paper. They disappeared as steel metallurgy improved, as rubber components entered wheel and bogie design, and as suspension systems advanced enough to manage the comfort problem from a different angle, not because they failed, because the industry moved on, and that is what makes this story genuinely worth telling. Paper wheels were not a quirky gimmick or a desperate experiment. They were a considered, effective engineering solution to a real problem, developed by someone willing to ignore the obvious answer and ask better questions. In an industry as conservative and standardized as railway engineering, that kind of thinking is always remarkable. Next time you sit in a smooth, quiet railway carriage and barely notice the track beneath you, maybe spare a small thought for the guy in 1847 who looked at a railway wheel, decided steel was the wrong answer, and reached for the paper. We think that deserves a little more credit than it usually gets. If you enjoyed this video, remember to subscribe for much more railway content. Leave a comment below telling us what other strange engineering solutions from railway history you would like us to cover next.